What if everything we've been told about artificial intelligence is built on the wrong machine? Not the wrong algorithm, not the wrong data, the wrong hardware. Because the computers we use today, even the most powerful AI supercomputers, are built on a design from the 1940s. And that design might make real artificial consciousness impossible. Think about it. Your brain processes sight, sound, motion, memory all at the same time. You see a face, recognize it, remember a name, and react emotionally in a fraction of a second. But inside a traditional computer, things don't work that way. Information moves back and forth between memory and the processor like cars stuck in traffic. This is called the von Neumann bottleneck, and it might be the biggest barrier preventing AI from ever becoming truly intelligent. Let's understand this through an animation. Imagine a computer like this. The processor sits here, the memory sits here, and every piece of information must travel through a single narrow channel between them. Fetch the data, process it, send it back, again and again and again. As the workload grows, that narrow channel becomes a traffic jam. This is exactly what researchers call the von Neumann bottleneck. Even the most advanced AI systems today, massive neural networks trained on trillions of words, are still just simulating intelligence. They calculate, they predict, they approximate. But they do not think in real time the way biological brains do. Why? Because silicon chips process information sequentially, but brains process information everywhere at once. Let's understand this difference through an animation. A traditional computer processes tasks step by step. One instruction, then the next, like a pipeline. But the brain works very differently. Billions of neurons activate simultaneously. Vision, sound, memory, and emotion all interacting in parallel. Instead of one pathway, intelligence emerges from massive networks firing together. Nature solved this problem hundreds of millions of years ago. Your brain contains roughly 86 billion neurons. Each neuron connects to thousands of others. And instead of sending digital zeros and ones, they send electrical spikes. Tiny bursts of energy that travel through synapses at incredible speed. And the timing of these spikes, even differences of milliseconds, changes how the brain learns. Let's understand this through an animation. Imagine two neurons connected through a synapse. If the first neuron fires just before the second neuron, the connection between them becomes stronger. But if the order is reversed, the connection weakens. Learning in the brain is literally encoded in the timing of electrical spikes. This process is called spike timing dependent plasticity. Now imagine building computers that work the same way the brain does. No constant back and forth memory transfers, no rigid binary logic, just millions or billions of artificial neurons communicating through spikes and continuously rewiring themselves as they learn. This field is called neuromorphic engineering, and it may be the only path toward machines that can truly think in real time. Neuromorphic chips don't just process data differently, they process it dramatically faster and with almost no power. Your brain runs on about 20 watts of energy. That's less than a household light bulb. Yet it outperforms many supercomputers at tasks like perception, reasoning, and decision making. Now imagine artificial systems with similar efficiency. Robots that react instantly. AI that perceives the world continuously. Machines that learn from experience instead of retraining on massive datasets. Companies and research labs are already building the first neuromorphic processors. These chips don't run traditional programs. They behave like digital nervous systems. Instead of computing step by step, they evolve patterns of activity, just like a living brain. And if this architecture scales, we may finally cross the most important barrier in artificial intelligence. Not bigger models, not faster GPUs, but a completely different kind of machine. For decades, we tried to create intelligence by making computers more powerful. But the real breakthrough may come when we stop building computers entirely and start building brains made of silicon. Because the future of AI may not be artificial intelligence at all. It may be synthetic consciousness. If you enjoy exploring ideas at the edge of science, technology, and the future of intelligence, consider subscribing. Because this channel is about understanding where the next breakthroughs are coming from and what they might mean for all of us.